Our final type of calculation in 6.2 is finding a molecular formula if we know the empirical formula. Remember, we can find the empirical formula if we know either the masses of each of the elements in grams or the percent compositions. Once we have an empirical formula, our first step is calculating an empirical formula mass. That is, the mass based on the empirical formula. Then we're going to take the molar mass of the compound, which would be given to us in the problem, and divide by the empirical formula mass that we would have just calculated in step 1. Our third step is multiplying the subscripts in the empirical formula by that ratio that we find in step number 2. Here's an example. We're trying to find the molecular formula of a compound which has the empirical formula of NO2. We're also told that this particular compound has a molar mass of 92.010. Our first step is finding an empirical formula mass. We're going to do the calculation as if the molecule were just NO2. We take 1 times the mass of nitrogen plus 2 times the mass of oxygen from the periodic table and add them up. The empirical formula mass would be 46.005. When we compare that to the actual molar mass of the compound, we see those two numbers are different. The molar mass is much larger, so our molecule must be larger than NO2. What we need to do in step 2 is find out how much larger than NO2 the molecule is. In other words, how many multiples of NO2 are there in our molecule? To answer that question, we find the ratio between the molar mass and the empirical formula mass. We take our molar mass on the top, that's the larger number, and divide by the empirical formula mass on the bottom, which is our smaller number. We've got 92.010 divided by 46.005, which gives us a ratio of 2. This is telling us that our molar mass, that is the mass of the molecule, is twice as big as what we'd expect based on the empirical formula. In step 3, we're going to take that ratio and multiply each of our subscripts in our empirical formula by that number. We had 1 nitrogen and 2 oxygens. We multiply each of those by 2, which gives us 2 nitrogens and 4 oxygens. Therefore, our actual molecular formula is N2O4. Nicotine contains 74.02% carbon, 8.710% hydrogen, and 17.27% nitrogen. If 40.57 grams of nicotine contains 0.2500 moles nicotine, what is the molecular formula? You're given percent composition. Remember, you're going to change the percent symbols into G for grams, change grams into moles, and then divide by the lowest number of moles to get the empirical formula of the compound. The empirical formula is not necessarily the same as the molecular formula. You'll have to apply what we just learned to take that empirical formula and change to molecular formula using the molar mass of the compound. The molar mass is not given to you in this problem directly. You're going to have to calculate it by using the relationship between grams and moles of the nicotine. We know that 0.2500 moles of nicotine corresponds to 40.57 grams. If you take grams and divide by moles, that gives you grams per mole, which is the molar mass. You'll take that molar mass that you calculated, along with the empirical formula that you will have calculated, and find the molecular formula. Is the correct answer A, C5H7N, B, C7HN2, C, CHN, or D, C10H14N2? The correct answer is D, C10H14N2. When we go through the steps of changing percent to grams, grams to moles, and dividing by the lowest number of moles, we get an empirical formula of C5H7N, which would be A, but that's not necessarily our answer, because it is only the empirical formula. We need to know the molar mass of the compound to see if that is the true molecular formula. To find that molar mass, we take 40.57 grams, divide by 0.2500 moles. That gives us a molar mass that we can use for comparison. What we find is our molar mass is actually twice as large as the empirical formula mass. That means we have to multiply each of our subscripts by 2, which gives us a true molecular formula of C10H14N2.